super quick and dirty. We have all seen the latest Apple demo of real-time image description using the VLM, visual language models, on their hardware. Someone somewhere posted on LinkedIn or Twitter, I don't remember where, but two things were brought to my attention. A, Llama CPP, way more faster backend, something that falls between, I would say, Ollama and VLLM, so that is more industry grade deployment, LLM management, MLOps management services, backend services, or backend engine, I would say, versus Ollama is very easy to get started. Llama.cpp, which is what Ollama is built on, essentially, is the core, I would say. And we have this, I would say, Llama, or my codes, Llama server, yeah. So I'm just pulling with the Llama server, which is the Ollama server, just like Ollama serve command. I'm pulling from Hugging Face SmolVLM-500M-Instruct GTUF for my Mac. Essentially, as you can see, I'm running Isotope, and NGL99 essentially offloads all the computation to this unified memory, or GPU in this case, unified memory. Port is port, simple. We're hosting it and binding it to all the services. So I have already downloaded the model, so it's going to be very, very fast invoking, and it's faster a little bit than Ollama, I would say. And then, yeah, ignore all these errors. And then we have a very small script, and all that does is takes two arguments: the image file to be passed, and a prompt to describe the image. For example, it has you can see the basic default prompt, and I'm just popping over the image just for easy side-by-side comparison of what the inference is, or description of the image the model gives versus the image we can see for this recording. It encodes the image in super fast base 64. I was initially thinking of trying to send a curl request from the terminal, but encoding in base 64 just overshoots the limit of curl's request quota, so cannot be sent. So very simple dirty Python script, proof of concept, just takes the image, defines the meme type, sends the request essentially with the prompt. And if we vary these things, we can play around a lot, and also the same family of the model to get varied results, more or less. This is one of those first ones, and then it just sends and prints the response, I would say, because there are many other things. We're just parsing out the core description, I would say, out of all of these, and that's all of it. So if our backend is running with the model, the 500 milliparameter small, and then if we just get here, and then we just run our scene.jpg, and you will see what that scene is, and this is our prompt: a house in the mountain with a pathway to it. If we run it again, we might get a little bit of a different result. A beautiful mansion sits in the mountain surrounded by lush greenery and majestic peaks. Almost right, but you saw how fast that is. If we run it again, a lodge nestled in the valley with towering mountains behind it. Fair enough. And then if we run it again, wow, this time it is a little bit different. So if we run it again, the house in the image is a classic two-story building. I think it's more than 2 stories. But you can see the overall atmosphere of the image. It can also go, because we have maximum tokens defined, the descriptions can vary, but you can see how fast that is. It's almost real time. And actually, funnily, we have to give the credit, someone has actually made a real-time version of it, so it's running as simple as that, one single index HTML file, and it is actually sending the request just like we were in our Python from here, and we're displaying the message, more or less. So if you want to try out something without the Apple intelligence, then open source local version, here you have fun, and off to the next one. Cheers.